Hey, so Thomas, how are
Hey,
you doing?
Luca, how are
Hey,
things?
hey. Well, I haven't packed my bags. Do you pack your bag? Not yet, right?
Not yet, no. I mean, it's still 2 days to go.
Yeah, to me, yeah, 2 days to go. I'm leaving Sunday morning for where? For where? For California. GTC is coming up.
Yeah,
Yeah, it's pretty crazy. Like I remember last year, it was my first GTC, in fact. Um, and I didn't expect it to be such a such an event. It was a lot of fun, and the keynote was pretty crazy. This stadium full of people and 3 hours long Jensen's show, and he has a very theatrical way of like very fun. Like it was a lot of fun. And you could actually pay attention for 3 hours. Like I was
yeah, I
mind
mean,
blown.
he's a professional in that by now too, right?
Oh yeah, absolutely. But I heard he rehearsed a lot. Like he prepared really well for that one. Um, so yeah, maybe this year will be even more exciting. But one of the exciting things that we've done this week is like seeing things run on the Blackwell chips with Thunder. So that was pretty exciting, and we're gonna say something about that at our talk on Thursday. So we'll have a Thunder talk. But a lot of the things we would say is something that our dear small group of aficionados know already. Although we'll show some results on Blackwell and stuff, and so that would be pretty nice. Um, but today, we're not going to spoil a whole lot, but actually a bit, yes, because we're going to show some of the code that we ran on Blackwell uh, this week. And it's about FSDP with fine tuning of, well, we've run a lot of 70 billion fine tuning, both full fine tune and LoRa. Uh, So we'll like to take the opportunity to show you a little bit of what we do there. We'll run at 8 billion just because it takes shorter, but we can also launch the 70. That there's no much, not a lot of difference there. So let's review for a second what we said last week, and then we can start. So I won't be drawing or anything. I will just want to review. So we said that you have a large model, more than one GPUs, right? And one of the ways you can run these things is by, if your model doesn't fit a single GPU, but it needs to be uh, distributed across. There are many things you can do. You can do tensor parallel, blah, blah. One of the nice things you can do is use fully sharded data parallel, which doesn't complicate your computations because you're still going to gather the full matrices right before you do the computation. But in fact, all the other layers or many of the other layers are sharded across GPUs. And so they don't consume all the memory. Only the things that are being computed upon are materialized on each GPU. And so you don't have to think about how to break parallelism along rows and columns for compute. But you can just compute your matrix multiplications full. Uh, and the other thing
Yeah,
is that you can overlap communication and computation so that you can materialize the full matrices while you're finishing to compute the previous computations. And so you can say bucket communications in a few moments where you will materialize a bunch of them, and then you just deallocate them. And then while you're computing those, you're then gathering another bucket of things and so on, and you move on like that. And one
yeah.
other thing you can, yep,
It's
go ahead.
like a bit of a choreography, right? Keep things
Absolutely, yeah.
conceptually
It's a
simple,
dance.
but you need to like have everything right happen right at the right time. Because if you
Exactly.
do it too early, it will take too much memory, right? Because you
Exactly.
need to materialize the things that you're materializing for the next step while you compute one step, and so That's where it's really, you need to know where
Yeah,
exactly to do what.
exactly. And then if you don't do that, then your GPUs will be waiting for communication, which is like equally bad, if not more. And so, yes, it's a dance, and it needs to be carefully synchronized. And then there are strategies like hybrid where you do FSDP within the single machine, the GPUs in the single machine, and DDP across. So you kind of aim to reduce the communication between machines, which is usually slower. And then we also mentioned that on the new NVL72 systems, they're crazy. They're like, it's like a computer with 72 Blackwell GPUs on them they're like really fast interconnected. So it's not like you have 8 and then you have another machine and the interconnect is slow. It's like super fast. It's one rack, but it's basically one computer. And on those, you can take advantage of it.
And during last GTC, Jensen said that it comes with a jacuzzi, right?
Yeah, we'll see if that's true this year. Yeah.
So it can heat water for a jacuzzi within a second or whatever.
Yeah, yeah. I hope to see some of those. I hope they will be there. It will be very interesting to see. They must be quite impressive. Do you remember how much cabling there was, or the weight of the cables? I remember there was an insane amount of
there
kilograms.
was a huge amount of copper, right? And the story was that making things go to light for fiber and then decode it again, that was too slow. Like, just do the real thing.
Yeah, exactly.
And it looks, of course, it looks a bit like in the olden days, right?
Yep.
Like those Cray machines that they put like on a toroidal shape in order to have like the best wiring and all wires of the same length and stuff like that.
Yeah. It would be nice if they made it like leather, red and white leather thing, like in the old days, the Crays were like that. And then we talked about how to load a checkpoint and save a checkpoint where you are in this situation where you need to kind of load lazily because otherwise you will go out of memory or you fill up your CPU super inefficiently. So what you do is just map your the file just like if it was RAM, and so you can basically the pointer to each fake pointer to a disk location essentially of each tensor. And then you can parameter by parameter load it, but you load it and you shard it immediately. So you can load pieces of the thing and as you go through. And this is not necessarily an easy, it's not super complex, but you need to know what's going on. So in all these things, you always need to know what's going on. We'll see how Thunder simplifies this and makes it simpler. And I think part of the talk that we'll give will kind of hone in on this point. And there's so many optimizations, so many kernels, so many distributed things. Now, how you put them together is becoming more and more complex. And Thunder is there to try to solve this problem. So let's go on the studio and see the 8 billion or 70. So this is a case where it's a fine-tune LoRa and non-LoRa fine-tune of a Llama model, and it's in its R1 variant, where you want to say, okay, I'm now fine-tuning on the input, reasoning traces, and output. It doesn't make a big difference from a computation point of view, but that was the inspiration for the use case.
Right. So so it's really easy to show, right? Here you say Python main because that's what fine tunes it. It's all set up, and let's do it with the 8 billion model, and you just start it. And
you're on a fancy 800 machine.
Now that Blackwell is all the rage. It used to be that H100s were hard to get, and now you can just here choose them as your machine here, and this is on GCP.
Wait, $6 per hour?
Yeah, that's really
Interruptible, you
not,
know?
yeah, and it's interruptible, but it has been running for like 3 days without me seeing any interruptions. So,
So $6. So wait a second, $6 for per hour for 8 GPUs, 8 H100s.
yeah,
Let's
imagine that.
imagine
That's right.
that. So just jump on the Lightning platform right away.
Right. And so with these 8 GPUs, I'm in a studio and I just started the thing, and you see that the formatting is not as cool as it should be. And the tricky part here is that there's some sequencing uh, that you need to do to disable the printing on all but the first thing. But you can see how it runs through it traces through the model, and we don't
Yeah.
know really what the upper limit here is. Well, we do know, but the computer, the program doesn't know at this point. But it shows you how long the trace is, the initial one, right?
Yeah.
And so what's going on there? That is not good.
What?
But I would,
Oh. Hmm.
yeah, I wonder if that is like from testing or whether that is from the current run. I don't know. Yeah, I think there are too many Pythons here. So
Yeah.
let's get rid of some and start afresh,
Yeah.
right? And we can check that there is no VRAM being used anymore.
Yeah.
And so, yeah, if you run two or three of them at once, then yeah, things are a bit slower on each of them. But yeah, so this will start again, and it uses Fabric, Lightning Fabric, and Thunder to do the distributed here.
Yeah. We can take a look at the code later, but yeah. So we'll be integrating Thunder and Fabric and PyTorch Lightning more and more. This is just an example that is in LibGPT, and we kind of took that to, yeah,
Right.
it's in the, where is it? In
So
the
we look.
extensions.
Oh yeah. So in the extensions we have the call to Thunder, and it's the
Yeah.
Thunder FSDP strategy, and it's not very cleaned up because I
Yeah.
mean, obviously the week before the conference, the code has to work. It doesn't have to.
Everything is valid. Like, yeah. Everything is valid. Software engineering goes out the door the week before.
Right. And so, but what you see is that here you have the FSDP transform, and it's innocent enough. And then you have the materialization transform because we trace on the meta device, and then we materialize. And so the transforms are just those three. And then we see that it just thunder.jits the thing with the module, the transforms, and the executors. And
Yeah.
that's basically it, right?
Yeah, philosophically, Fabric and PyTorch Lightning have never cared too much about the model. Like they would wrap the model, but they would not own the model. The only two exceptions being the Transformer engine plugin and the Bits and Bytes plugin that we introduced at some point, which is when we were convinced that we needed to do better because those just replace the linears, which is totally fine, but it ends there. So uh, to do all the optimizations that you need to do nowadays, you need to really understand the computation. And yeah, so we'll
Right.
be integrating more and more.
Yeah. So this is the the FSDP, and then here's a LoRa training script that we took from LibGPT, and basically at the right point you just give Fabric the Thunder FSDP strategy, which was the thing that we just looked at, instead of the model parallel strategy, which would be like wrapping things in FSDP wrappers and stuff.
Yeah, model parallel strategy is what you use if you want to use the new Torch distributed stuff. And there's a blog post, release notes for the PyTorch Lightning 2.5 that report some of these things. And so this code works both for Eager and Thunder. So that's why you see model parallel here. But and what else? Oh yeah, we are about to release a patch release for PyTorch Lightning that will stabilize support for PyTorch 2.6. I think it should happen any minute, so that's good.
Yeah.
Just as an aside. Oh yeah, and we are also updating Studios and updating the compiler toolchain because we are upgrading the base images, so it will become easier to do kernel development and compile custom kernels on Studios. That's super exciting.
Yeah. So lots of things going on. This is still tracing.
Yeah, at some point we will rewrite, No,
yeah, at some point, I mean, we do have various caching things, and this was also something that we did. We put some infrastructure into place to make the caching easier and cleaner. And so, this will be soon too.
Yeah. Great. All right. Because then it will start. So we have 8 billion, 13 million parameters are trainable because of LoRa. Do we know what LoRa is? Yeah, we do now.
I don't know.
We never talked about that.
Do you want to show? Or not?
No, I mean, it depends on how long this will take, but I think we should be all about right. But anyway, just as while we're waiting.
Yeah, it's a little under 3K, so you still have 700 operations to go.
Okay, really quickly. So with LoRa, you freeze your model, and then you add some linears that add to the result of what your model does. So for example, if you have the projection matrices in attention or the MLP, instead of training those matrices, you introduce different matrices that go parallel to those, and you train those. Now, why LoRa, low rank approximation? Because those matrices are not full matrices, but they're actually the product of a very tall vector and a very long row vector. Or a few of them, a block, like a very skinny one and a very short one. And when you multiply those, you re-obtain those two things, you re-obtain the full shape. But you starting by these like two skinny matrices, you will have a number of parameters that is lower, which will lead to a full matrix that has lower rank. So you train those small sets of parameters, and that is you can set up like a rank of 16 or 32. Rank means how many rows and columns that are linearly independent you have in the matrix. Meaning you can obtain, given 32, you can obtain the whole thing. With some linear transformation, linear combination. And surprisingly, that is enough to change the style of a conversation and so on. So it's kind of like the model already has it in there. And you're kind of tweaking, like tilting things in just enough so that you extract different things from the model. Especially because most people doing LoRa, not all of them, but they're only training the attention. I think it's Q and V projections. You can also do a LoRa on all the matrices.
Yeah.
Oh, here. Oh, it's working. Great.
So here we are, and if we look at the iteration time, it takes like 250-ish seconds, I'd say.
Milliseconds, yeah.
Milliseconds. And so, yeah, this is, of course,
Yeah,
this does not tell you anything without the side-by-side comparison, right? So,
but if you go up to the VRAM, we can see how things are there. So the
yeah,
RAM is like not super full because we are not basically storing too many gradients because most of the parameters do not have requires grad equals true.
right.
Because
Or,
just only the skinny ones do.
yeah. So the size of the parameters that have it is small, right?
Yeah, yeah,
And you
it's a
can
few
also
million.
see that it's utilizing the GPUs relatively well.
Yeah,
So that's good too, right?
yeah, and this is basically the FSDP that we have seen the last time, right? It's the same transform, and it
Yeah,
fits in a file, so you can see. And now, if you go on a different machines that has a different, I don't know, like you're in the new architecture, like Blackwell. You're very lucky. You are on NV72. Now you need to tune it, and you discover that you need to bucket things differently. Yeah, here you stopped it. Yeah, you need to bucket things differently, right? Because um, it's so fast that you need to materialize them earlier in order for them, and it's so fast in compute and so fast in communication that you need to change the place where you materialize the tensors. All you need to do is to go back into the FSDP transform and adopt a slightly different logic on when you call the gathers, right? And that's all you need to do. You just need to look at that file and tweak that. And that gives you superpowers.
yeah, and yeah. Now we can compare with the eager, and of course this also gets stuff done. But if you look at it, you will see that it replaces the block with a FSDP block, and the
Mm-hmm.
GPT with FSDP GPT.
Mm-hmm.
And so those things are like where you have to have uh, adaptation in order to do the FSDP, right?
Yeah, this would make it a bit trickier probably to compose different things, right? That now, if you want to quantize or have a different precision, yeah, and here we see it's a bit slower. It's about 290, and we
Yeah,
were 250. That was with the default executors. So maybe with different executors, special kernels, you can reduce further. On Blackwell, you have FP8 precision. So sky's the limit in composing the different things you can compose. Since you can compose them with Thunder, now you can mix and match and try whatever. Um, And the other thing is we are working at, maybe that's something I can show, unless you want to show
no,
the
you
trace or
can
something.
show.
Yeah. So out from the presses, not even because it's still in the presses. I'm working at something that, and you will ask, didn't you work on it before? So it was actually ready by the time. No, that's happening just in time because that's how we roll. um, so do you remember some time ago we did an episode with recipes, and right now, yeah, we brainstormed a lot about recipes and the ability to add what we now call plugins and to compose things simply at the top level. Because one of the problems, well, not problems, well, one of the things that you need to do with Thunder is knowing what is a leukocyte, what is a transform, what is an executor. And for users coming in Thunder and wanting to just run their stuff and try different things and mix and match, then we are introducing an API that is that it looks like this.
Can you make it a bit larger, this font?
And of course I can, yes. I didn't think about it.
I mean,
Okay.
I have my special glasses for Thunder.
Okay. The Thunder glasses.
Yeah.
So this is the way you will call, like, for example, you have a bird model here, and you instantiate it, and now you want to call Thunder on it, like disregard all these things here. But the way you will do it is you instantiate the model. You can also instantiate it on Meta device, which is not CUDA, which will be saved for your memory, so you won't go out of memory. And then you say, okay, by default, you will not need anything because, Hugging Face transformers are quirky and they have things inside that we need to tell Thunder how to manage, like some data-dependent control flow and other things. And
checking things that might be always true if you're knowing what you're doing.
Exactly. Exactly. Or warnings that are data-dependent somehow. And so we basically build lookacides for them in this Hugging Face transformer recipe. If you have another model, like a Torch Vision model, you won't need any recipe. But in the future, in the near future, probably even next week, depending on what I do during the flight, the default will be auto. And so when you do recipe auto, it will auto select based on what the model is. It will just, bring the right recipe in or try to do the right thing there. And recipes may also have interesting options and so on. So in Lightning style, if you need to further customize, you will be able to just instantiate the recipe. Basically, the string is a shorthand for the class instantiation. If you use PyTorch Lightning, you're very used to this pattern. But this will not, this could already contain FSDP stuff and so on. So many executors and transforms. But we wanted to make sure people could come and mix and match and experiment quickly without subclassing or, having always hyper specialized classes. So what we introduce is the plugins. So plugins will be things that you add on top, and it could be a list of things or one thing, and it could be FSDP or and, for example, FPA. And this is the way you will just run all the transforms executors all bundled in, and you will get a Thunder model that knows how to load itself, for the loading, I think we will need to do something like that. If you want to load the way you saw, probably it will be like checkpoint equals blah, 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 right?
Yeah.
And then you will have FP8 and then CUDA graph, we're still debating whether it's CUDA graph or reduce overhead, whatever. But my point is that this way will be very quick to be able to transform your computation on the fly and experiment with it. This is the Thunder model, and then you will just be able to have a training loop here, and that's it. So this is landing. Awesome. It's pretty exciting. It's coming up. It's bubbling up to the at the top. So these are all things that we will present next week, along with numbers and benchmarks. And so, hopefully it won't be too, hopefully we'll land everything by kind of Tuesday.
Yeah. So do you think Lightning will have cool t-shirts? Like the t-shirt they had for the last GTC, that's my favorite Lightning t-shirt ever.
Yeah, I don't know. I haven't been made aware of the swag, but there will be swag. I don't know if cool t-shirts. I hope so, though, because, I love them. My family is very eager to get more T-shirts of that nature.
Yeah,
My
I
kids
mean,
love them.
in hindsight, I wished I would have grabbed one or two more. But yeah.
Awesome. Okay, so have a great weekend, and
Yeah,
see
and
you there.
see you there, and maybe we will have something exciting, and probably will we do an episode next week? Probably not, right? Or
I don't know. Like, are you around on Friday? Sorry, it's our stop, but
I might be. So maybe there will be an episode
maybe.
next week.
Yeah,
And
it will be the morning in California, so maybe Friday morning we'll get
yeah,
that done. We'll see.
super
Maybe
good.
something direct from the floor at
Yeah, live.
GTC. Live. Yes, yes. We should do that.
Super good.
Nice. Okay. Bye,
See you.
Thomas. See you soon.